Okay, so valves. Common parts of the valve are pretty much every valve has body, plug, guides, and a seat. So 4 common parts of a valve. There's some different characteristics for automated control that are important. Your flow characteristics, so you have a relationship between the flow rate through the valve and the valve travel. So that's different for different types of valves. Some will, if you open it up 10%, it'll actually allow a lot more fluid through it than another one where you have to open it up, say 60% to get that flow. So that's kind of the flow characteristics, and it will be, I think I put up a plot in here that you can see that. Pardon me, flow capacity, the smoothness of operation. I mean, it's really important that you have a valve that doesn't slam open, slam closed, and such when you're controlling it automatically. It needs to be fairly smooth. You don't want the leakage through there. So, because some valves are actually just designed so that they don't have a real tight seat. In some cases, actually, that might be okay, but most of the time you want to be able to control that flow through there. Ease of maintenance, of course, and then some of them are actually designed so that they'll clean themselves and that you won't or won't get solids or gum up in there. So they're kind of designed in that manner. Two types of valves that I think are very important, and I apologize, I couldn't find a good picture of a back pressure regulator, so I relied on something that I had from another professor's notes from a long time ago. So I think it's important to know the difference between a pressure regulator and a back pressure regulator. So when you're talking about a pressure regulator, you're trying to maintain a constant pressure downstream of the valve. So if you look at these, you see the flow through here. And what you can see is this little opening here. That's so the gas, or more than likely, this is typically pressure regulators are on gas, the gas outlet. The gas can flow through that little opening and put pressure on this diaphragm that's right across here, which of course pushes on the spring, and the spring's set to a certain amount of force, so that if you need more flow, you're maintaining pressure down here. So if you want to maintain 120 psi downstream, and let's say we don't have enough pressure, it's going to allow that spring to push down and open this seat more. Does that make sense? Whereas, and this is kind of a double acting valve, you have two different seats here. And this is going backwards. That was, like I said, the only diagram I had, but you actually have the opening that's allowing the gas pressure on the valve from the upstream side. So it's getting its signal from the upstream side and say, hey, we want to hold it 120 psi here. Right now I'm hitting up about 123, so it's going to push up, and this will be a direct acting or indirect acting valve. It'll push up and open that valve. Okay.